Welcome to my YouTube channel. Today I'm going to be talking about integration by parts, and in this integration you have to be remembering the quotient and the product rule of differentiation, and therefore in this case the product and the quotient rule of differentiation says that, let's like, if we have dy dx would be equals to we have the du dx minus plus u dv dx. But in this case here we stated that we say that y was equals to uv. That's why we got that. So after that you find that for integration by parts, here we can get, let's like, a formula from here. So we say that if I have my dy dx would be equals to v du dx minus u dv dx. Oh, it is a plus. So if I out of that, I'm going to say that this is dy, which would be equals to v du dx. This is dx plus this would be u dv dx dx, and therefore this would lead to integration. So out of that, if you remember, this is d, of which our y is u v, minus this is going to be equals to, so this would be integral of v du dx plus the integral of u dv dx dx, here also dx. So having all that, then afterwards I'm going to make this only the subject, this the subject. So after, let's like, making it the subject, then I'll get my expression, and therefore this would be equals to, I would have, this is going to be just uv equals to the integral of v du dx dx, yes, plus the integral of u dv dx dx, and therefore I'm going to have, this is going to be uv minus, I'm going to have the integral of v du dx, which would be equals to the integral of u dv dx dx. So this dx. This would be also here, have dx equals to that. Now, having done that, you find that during our expression, you find that, let's like, mostly we are going to base on something, let's like, based on mostly this for our integration, and we shall be, let's say, naming our, let's like, our variables using this, of which one will be u and another one will be dv dx. Now, given an example, if I have, for example, I've been told to integrate x cos of x dx. So if I'm to integrate this, of course I'm going to label them and say let u equals to x. So I'm going to differentiate this and say du would be equals to dx, and therefore du dx would be equals to 1. At the same time, if I say that, if I say that dv dx would be equals to cos of x, and therefore I'd say that dv would be equals to, I'm going to have something like this is going to be cos of x dx, and therefore this would call for integration. And therefore I'm going to come here and say that this is v, which would be equals to, I'm going to integrate this, and I'm going to get here sine of x. Having got that, then I go back and say that since our expression was saying that I was having u, of which my u in this case was x, then dv dx, which is cos of x dx, would be equals to uv, of which my u is x, v is sine of x, minus the integral of, I'm having looks like then the other part was saying that we are having here v, which was sine of x, then du dx, which is 1, and therefore this would be dx. And therefore here I would come here and say that this is equals to, I would have here, this would be x sine of x minus, this is going to be, if I integrate this, I'm going to get negative cos of x, yes, plus an arbitrary constant, and therefore I'm going to say that this is x sine of x plus cos of x plus c, and therefore I'll come out with my result as this. For the second example, if I have, for example, I've been told to integrate, for example, I have that integrate x sine inverse of x respect to dx. So you find that here I'm going to say let u equals to sine inverse of x, and dv dx be equals to x. So here I'm going to say that this, for this, let me first work out for only this. So you find that I'm going to see that sine of u be equals to x, and therefore this, if I differentiate on both sides, I'm going to get cos of u du will be equals to dx, and therefore du dx would be equals to, I would have 1 over cos of u. But I know that cos, this, for this cos of, let's like cos of u, you find that this is du dx would be equals to 1 all over, we are having this, this will be a root of 1 minus, this is sine squared u. After getting that, du, so du dx will be equals to 1 out of which sine squared, we know we had sine of u, which was represent something, so this would be 1 out of this would be 1 minus, and if I'm having this, of which I'm having this, and I can represent it by x, of which this would be x squared. But we say that dv dx was equals to, we're having here x, that means that v would be equals to x squared out of 2. Having got that, we are now putting it back into our expression. So if this is placed back to be integrated, this would be uv, of which my uv in this case, the integral of u, of which my u is sine inverse, and then dv dx, of which the x was x, so this is x, sine inverse of x, the x would be equals to, so I'm going to have my uv, which my uv in this case would be x squared out of 2 sine inverse of x minus the integral of, in this case I'm looking for my v, x squared out of 2, so I'm multiplying this times 1 all over root of 1 minus x squared, so the x. So having got that, then afterwards I'm now supposed to work out only for this. So let me first let's say extract the expression, and then afterwards work on it all in whole. And after that, I'm going to come here and say that now I'm going to extract out this one of this a half, then afterwards I go on. Therefore that means that I'm having x squared out of 2 sine inverse of x minus the integral of I'm having here x squared out of root of 1 minus x squared. Yes, this would be the x, but outside I'm having 1 out of 2. I'm having here 1 out of 2, therefore this is going to be x minus 1 out of 2. So having got that, then afterwards, if I look at this is an identity for sign substitution, and therefore if I say that let x equals to sine of u, and then let me use another letter this case. Let's say sine of k, and therefore I'm going to have here and say that the x would be equals to, I would have here cos of k dk, and therefore I would have here this, I'm looking for dx, of which I make dx the subject, and therefore I come here and say that this is going to be x squared out of 2 sine inverse of x minus 1 out of 2 integral, I'm going to have x squared all over root of 1 minus, which x squared would be sine squared k, then multiply this by cos of k dk. So out of that I come here, the whole of this would go with this, and therefore I would have x squared sine inverse of x minus, this is going to be 1 out of 2, yes, the integral of which x squared be sine squared of k, yes, sine squared of k dk. Having got that, then afterwards I come here, but I can with integration over even powers, you find that I can represent something here. So if I'm going to say that this is x squared sine inverse of x minus, this is going to be 1 out of 2 integral of 1 out of 2 to 1 minus cos of 2k dk, and therefore I come here and say this is x squared sine inverse of x minus, this is going to be 1 out of 4, 1 out of 4 integral of 1 minus cos of 2k dk. So if I'm to integrate this, I'm going to come here and say that this is x squared sine inverse of x minus 1 out of 4 into, this is going to be k minus sine of 2k out of 2, yeah, plus an arbitrary constant, of which I'm going to have, this is going to be x squared, yes, x squared sine inverse of x minus k out of 4 minus, this is sine of 2k out of 8 plus an arbitrary constant, of which if I'm to present this, I can find that, let's say like this shows me something. So I have to convert this sine of 2k into, let's say like into a full expression such that I can represent it in the other way around. So I'm going to come here and say that this is going to be x sine inverse of x minus k out of 4 minus, this is going to be something like, I'm going to have 2 sine of k cos of k all over 8 plus c, of which on the other side, let's try to work it out. So if I have x squared out of 2 sine inverse, if I have, let's say this, then I'm having x here minus k out of 4 minus, this is 2 sine of k cos of k all over 8 plus an arbitrary constant, of which previously I think we forgot something. This was supposed to be squared out of 2, squared out of 2, squared out of 2, and this was also out of 2, out of 2, yeah, I think that was the problem. And then afterwards, this is what we have. So, but we know less like sine of k, where we substituted for k, we find that out of that, that's where we could look for. So we find that sine of k was equals to x. Sine of k was equals to x. Now, we have to also find in terms of this. And therefore, if sine of k is equals to x, that means that I'm going to have x squared out of 2 sine inverse of x minus, now k is sine inverse of x out of 4 minus, this is going to be, this is 2, yes, x. So let's say like this is going to be root of 1 minus, this is going to be sine squared k, yes, all over 8 plus c, and therefore we shall have here x squared out of 2 sine inverse of x minus sine inverse of x out of 4, then minus we are going to have here, this is going to be x root of, this is going to be 1 minus, this is going to be, this is we're having here x squared all over, this is 4 plus c, and therefore here we shall be having, of which if I take the whole of this the other side, so this will be, I think this like this would be, because this is a sine inverse, this is a sine inverse, but though there is some difference of separation, and therefore I would consider this as part of my work. And therefore you find that just there's like, if you have something, you have to, like for example, I was having this, then I had to try to express it back into, let's say like something whereby I could get my various balls back. So that's why it's like I had to use this, because I consider this as a double angle. I had to expand it and then afterwards convert it back into, let's say, something that I could work out very easily out of that. So you find that let's try another number. That if I have, for example, I've been told this like to integrate, for example, ln of, for example, I'm having x squared minus 4 is equals to that. This is like the x. So out of that, I know that it's like I'm going to let u would be equals to x. Let's say no, it is a ln, and therefore I'd have this would be ln of x squared minus 4, and therefore I say that this is the u, the x would be equals to, I would have, now if I'm to differentiate this, if you remember integration, let's say like natural logarithm, you find that I'm going to have, this is going to be 2x all over, this is going to be x squared minus 4, and if I'm having my dv dx, yes, being equals to, I'm having 1, and therefore v would be instead x, or x, of course, that's like not x squared. So out of that, I come here to select to put it back into our expression. Find that this, if I say the integral of u, of which my u in this case would be ln of x squared minus 4 v, which would be multiply this by x dx, this would be equals to, I'll have uv, of which my u in this case would be that, and then x ln of x squared minus 4, and then after getting that minus, I'm going to have the integral, yes, the integral of v, of which v is x, yes, then the du dx, then I'm having 2x all over x squared minus 4, then the x. So here I'm going to have something that will be informal. I'm going to have 2x squared all over this is going to be, I'm having here x squared minus 4, but remember we're having this like one that was subtracting, having x ln of x squared minus 4. So out of that, if I look at this only here, it will result into less like a partial fraction something, and therefore I have to think about something that is in partial form. So if I have this, and then let's like I want to convert, I first look at the denominator. Denominator is a difference of two squares, a difference of squares, of course. So you find that I have to first convert this. So I'm going to pick only this out and then work it out. So initially, if you look at this, yes, they're having this like I'm having x squared. So you find that this is in improper form. So I'm going to come here and say that let me first pick out that I'm having, let's like the integral of 2x squared all over x squared minus 4 dx. So let me first work it out. So you find that I'm going to come here and say that I'm having, this is going to be 2x squared, I'm having x squared minus 4. So x squared divided by this, I'll have 2. Then 2 times that, I have 2x squared minus, this is going to be 8. And therefore, I'm going to come here, yes, minus 8. And therefore, if I'm to subtract here, I would get something that this is 0. And then this would be 0 minus 8. And here I would remain with 8. So here I'm going to say, this is going to be like having root of, so the integral of 2x squared all over x squared minus 4 dx would be the same as someone having the integral of something, which would be, I would have 2 plus, this would be 8 out of x squared minus 4, and then this would, the whole of this would be a dx. And therefore, so let's say to work out this, I'm going to say that if I'm to integrate this, of course, I'm going to have 2 the integral, this is the x, yep, plus I'm going to have the integral of 8 all over x squared minus 4 the x. So after getting that, I'm going to come here and say that, like for 2 and the x, this would be 2x, of course, divided by 1, which is meaningless, and therefore I'm going to have this like a plus. I'm going to have 8 all over x plus 2 x minus 2 as a difference of 2 squares. This would be the x. Yes, I'm integrating that. And therefore, let's say to pick out this. So I have this as my main factor. Yeah. So I'm done there. So I'm going to come here and express this in partial form. Therefore, I would say that 8 over x plus 2 x minus 2 would be equivalent to a out of x plus 2 plus b out of x minus 2. Therefore, this would be a into x minus 2 plus b into x plus 2. All of this all over x plus 2 into x minus 2. So for general equivalency, I'll be comparing 8 with the numerator, of which the numerator I'm having a into x minus 2 plus b into x plus 2. So by comparing by this, I'm going to say that I'm having 8 equals to a into x. For proper substitution, a minus 2 plus b into x plus 2. So I'm going to have here, if I put in a positive 2, I'm going to have 8 equals to, this is going to be 0, and b into 4. And therefore, I would have 2 for b. At the same case, if I put in as like a negative 2, so I would have 8 equals to a negative 2, this would be a negative 4a, and therefore negative 2 will be equals to a. And therefore, in partial form of this, only this one, I'm going to have of the whole of this. The partial form of this would be so let's put here the integral of 8 out of x minus 2 to x plus 2 dx would be equals to the integral of which my a was negative 2 out of negative 2 out of x plus 2 dx plus the I'm having 2 all over x minus 2 dx. So this would be equals to, I'm having negative 2 integral of x plus 2 plus, I'm having this like this is going to be integral of, this is going to be 2 integral of, I'm going to have x of x minus 2. And therefore, I'm going to have negative 2 ln of x plus 2 plus 2 ln of x minus 2. So now let's like to keep out to bring everything together. I'm going to come here and start collecting. For our first integration, we're having x which was like we came from here and then we were working out. So this is going to be x ln of x squared minus 4. It's going to be the whole overall thing will be equals to x ln of x squared minus 4. We're having a minus. So having got this, we're having a minus. Then when we worked out this, that, we came up and got a 2x, and therefore we put it in the bracket. So into 2x. After putting it in the bracket, then when we worked out this, we came here and we got our ln. Yes, we got our ln, but look at the signs very careful. It was a plus, and a plus, since the plus is there, and therefore we continue with our plus, and then a plus, which is going to be, we're having 2 ln of x minus 2, then minus 2 ln of x plus 2, close the bracket. So this would be equals to x ln of x squared minus 4 minus, this is going to be 2x plus 2 ln of x plus 2. Yes, then minus, it is going to be 2 ln of 2, this is going to be 2 ln of x minus 2 plus an arbitrary constant, and then therefore this would come as your working. So it is very inappropriate that let's like okay, somehow disorganized, but as you follow up, you find out less like you follow the connection, and then afterwards you'll be getting something out. So for the next number, if I'm having, for example, been given, for example, I've been told to, for example, to integrate, I'm having x squared ln of x dx. So in this part, I'm going to say that let u equals to ln of x, and therefore the u dx would be equals to 1 out of x. Having then that, I would say that having got this, I would say that then the v dx would be equals to, I'm going to have x squared. So that means that v in this case would be x to the power 3 out of 3. So at that same time, I'm going to have something that would be, after working out this, first remove this. So you find that after working out this, I'm going to say that since the integral of u, of which u is ln of x, u, then dv dx, which is going to be x squared ln of x dx, would be equals to, of which my uv would be x cubed out of 3 ln of x minus the integral of v x cubed all over 3. I'm multiplying this by, I'm having du dx, of which du dx would be less like, I'm having, for example, du dx would be 1 out of x dx, and therefore this would be equals to, I'm having x cubed out of 3 ln of x minus, I'm going to have here, this is going to be integral of x squared out of 3 dx. So this is going to be equals to x cubed out of 3 ln of x minus, this is going to be x to the power 3 all over 9 plus an arbitrary constant. Now suppose let's like we've been told again to integrate. For example, I'm having x sine squared 2x dx. You find that I will say let u be equals to x, of which u dx would be equals to 1. And therefore I say that let dv dx be equals to, I'm having sine squared 2x. And therefore in this case I would have this being equals to something, and I'm having this like if dv dx, so I say that v would be equals to the integral of, I'm going to have sine squared 2x dx. And therefore to integrate this, I know that let's like if I'm having v equals to 1 out of 2, yes, integral of 1 minus cos of 4x with respect to dx. And therefore this would be, I would have, let's like 1 out of 2 minus 1 out of 2, yes, dx minus cos of 4x all over 2, we're having here dx. And therefore I would say that this would be equals to, this would be x out of 2 minus, I'm having this, and therefore I'll have minus, this would be sine of 4x all over 8, yes, for this. And therefore let's like if I put it into a major expression, the major expression so I would have, let's say like this would be the major expression, I would have x squared all over 2 minus, yes, minus, so you find that I was having 1. So let's like having, for example, let me first do it the other way around. So if I have, for example, this, but I know that I say that, so I have to say what is uv, of which my v is this, and therefore uv, of which my u in this case is x. So x will be x squared over 2 minus, this is going to be x sine of 4x all over 8. Now minus, and then I'll have the integral of v, of which will be x out of 2 minus sine of 4x out of 8. Now remember it is v du dx, which was 1, and then here we say that this like let's multiply this by dx. And therefore I'm going to come here and say that I'm going to have x squared out of 2 minus x sine of 4x all over 8 minus, I'm going to have, let's like this is going to be the integral of x out of 2, of which this x, x out of 2 dx minus, I'm going to have the integral of, and let's like minus, because let's say this will turn into a plus, so this is going to be sine of 4x all over 8 dx. So having got that, I'm going to say that this is going to be x squared out of 2 minus this is going to be x sine for x out of 8 minus this is going to be x squared out of 4 plus I'm going to have this is going to be negative cos of 4x over this is going to be 32 2 yes plus an arbitrary constant, yes, an arbitrary constant, and therefore you find that comes out very well. So thank you for watching. It's like, if you like the video, give it a thumbs up, and don't forget to subscribe for any update on this YouTube channel. With great thanks again, thank you for watching, and don't forget to share this video. Let's like out to your friends if you like it. Meet you next time.